So very good morning, student. So in unit number 2 of power electronics subject, it is phase control converters. So the topic which we are going to discuss today are what is the effect of source inductance, then what are the various performance parameters, and then finally what and all the various firing scheme for a converter. So this three topic we will discuss today. So this is the syllabus of unit number 2. So already we have seen a 2 pulse, 3 pulse and a 6 pulse converter we have already seen. So today we will discuss about the effect of source. Load side inductance we have already seen when we are seeing about 2, 3 and 6 pulse converter. So today the source side inductance, performance parameter and firing scheme for converters we will discuss. So moving on to source side inductance. So if there is an inductance on source side means, see, you get an power supply from TNEB and that power supply is coming from roadside transformer. So that roadside transformer is made up of inductor. Okay, so that inductance is going to play the role. That is called source side inductance. So it has a significant impact on converter performance because the presence will alter the output voltage of the converter. So if there is an inductance on source side, that will try to alter the output voltage waveform of a converter. As a result, the output voltage reduces as the load current reduces. In addition, the input current and the output voltage waveform changes significantly. Source inductance effect is analyzed for both single phase and a 3-phase converter. Okay, so now we know the property of inductor. Inductor doesn't allow rate of change of current, and if the load is unable to get the current, obviously the voltage will reduce. That is what is being told. And the field of electricity sorry for the inconvenience. The field of electricity should be always compared with flow of water. The flow of water will always match with flow of electron. Okay, since flow of electron is totally imaginary, but the flow of water is 100% we can visualize. So we take always example for the flow of electron is a flow of water. You can see water will flow only from higher potential to lower potential. I am right. Why, that is the reason why we build the tank on the rooftop. You have to pump the water to the tank. So from tank you can get the water in all the pipe. The reason for getting is there is a potential difference. Same case, only if there is potential difference your electron or current will flow. If there is no potential difference, no current flow. Okay, so one should be at higher potential with respect to other. From the higher potential to the lower potential you will have. Okay, then pipe from the tank. If you are running a small dia pipe, then the water coming through that pipe is depending on its diameter. So if you put a big dia, your tank drains at a faster rate. If you put a small pipe, your tank will take more time to drain. Same case in water also. In dam, if you put a big opening on the dam, nothing will be there behind the dam. All the water will try to flow. Okay, now the flow of water depends upon the resistance. Similarly, flow of electron also depends on resistance. Okay, so you are opening your dam, the water is flowing. If the water is allowed to flow on mud, if the water is allowed to flow on floor, if the water is allowed to flow on marble or tiles, there will be a change. In mud, more water will be absorbed, only less water will travel, which means it is offering more resistance. Same case for electron. If the resistance is more, the electron will come, flow of electron will get reduced. Similar way, if the resistance is reduced, the flow of water will increase. Similarly, flow of electron will increase. Okay, so now we are going to start with single phase converter. So in a single phase converter you are going to take source side inductance. Okay, now due to the source side inductance, what happens? Assuming that converter operate in continuous conduction, you are not giving any gap. Gap is, see, initially you will fire T1 and T2, then you will fire T3 and T4. Between T1, T2 and T3, T4 firing, there is no gap. That is why we call it as continuous conduction. The ripple from the load current is negligible. Okay, leave it. The open circuit voltage become equal to average DC voltage at the firing angle alpha. The diagram below shows the fully controlled converter with the source in a single phase. Thyristor T3 and T4 are assumed to be conduction at a time t is equal to 0. Okay, so now you see, during positive off cycle I told this two fellow are in conduction. During negative off cycle this two fellow is conduction. So at time t is equal to 0, when you start at time t is equal to 0, then only you are entering into positive off cycle. So before entering into positive off cycle, what should be there is nothing but it should be in the previous negative off cycle. So in previous negative off cycle, we all know that T3 and T4 will be in conduction. That is what it has been told. The thyristor T3 and T4 are assumed to be conduction mode when t is equal to 0. On other hand, T1 and T2 fire when omega t is equal to alpha. So you are going to fire at alpha. So we are not firing at 0, we are going to fire at a value called alpha. So even when there is no source impedance, if not there, then commutation will be occur at T3 T4. T3 T4 will turn off if there is no source inductance. Just underline this point. If there is no source inductance, once T3 and T4 at a time t is equal to 0, they will get turned off. I repeat, if there is no source inductance at a time t is equal to 0, T3 and T4 will get turned off. Immediately thyristor T1 and T2 are switched on. I will switch on by giving firing pulse. This will leads to input polarity to change instantaneously. In the presence of source inductance, what will happen is T3 T4 will not come to off at all, and at that time you might have turned on T1 and T2. Now what will happen? It is mere short. All the four switches will come to on. So thus T3 T4 does not communicate as soon as T1 T2 are switched on. So at some interval all the four thyristors will be conducting, and this conducting interval is called overlap interval mu. Okay, two more questions they can ask. What is called overlap interval? Then you have to say it is an instant at which all the four thyristors named T1, T2, T3 and T4 are in conducting state. Okay, so if this happens, so this is what we mean to say the region of mu. See here your negative thyristor, we will try to switch off. Since source inductance, it is continuing its conduction and it try to reach this instant where I have turned on T1 and T2. So now there is a both simultaneous existence of all the four for a particular duration of time. Then T3 T4 will vanish. So this is the region where both both positive off cycle and negative off cycle switches are in conduction. So this is T3 T4, no issue. When you come here, it is T3 T4 T1 T2, then this is T1 and T2. So this instant alone all the four will be there. So this will try to make your circuit such that it is mere short. So during this portion your output will go to 0, and that portion is nearly you are shorting. Okay, resulting in failed commutation when alpha is close to 180, and this is shown in the waveform below. So this is happen when there is a source inductance. I repeat, due to source inductance, what is happening is at an instant of small time interval where all the four switches will get turned on. All the four switches, if it get turns on, it is mere shorting your source. If mere shorting take place, then your fuse will also blow up. See here, it starts from here, go to T1, go to load and come to T4. So it is mere short. Okay, so that is the issue. Similarly, the effect on 3-phase converter. Just like a single phase converter, there are no instantaneous commutation due to the presence of source inductance. Here it is some more complicated. That is, when this T1, T4, and T5, T2, this 4 switch will try to on at a particular time. There what will happen is there will be a line to line short. Okay, line to line short will occur, and in second case this 4 switches and the second 2 lines will get shorted. Again, if this switch, this 2 switch and this 2 switch will make other 2 lines get short. So there it is phase to ground, here it is phase to phase. I think you might have studied in machines the issue of phase to ground compared to phase will be worst. So phase to phase is worster than phase to neutral. So phase to ground is 230 short, phase to phase is 415 short. Think of 415 short. In 415 short, when 415 voltage tries to come to 0, think of current which will be flowing, which will be 5 times the value, and even insulator will fail. Okay, that leads to so many issues. So care should be taken that if there is source inductance, what is the thing you have to do is you have to give some gap, so that in that gap the previous leg will go to off and then you are on. So you should give a gap. So without gap you should not fire. So alpha should be kept in such that when the alpha of firing which you have given, at that time the previous leg is in off. Okay, that care you should take, so that you should be very cautious. So now let us move on to the second part of today's discussion, which is performance parameter. It is an important to determine the performance parameter for different converters whose topology can be single phase or multi-phase. Okay, we have already seen about 3 pulse, 2 pulse and 6 pulse. So in 3 pulse we have seen 2 types of configuration. So put together you get half 3 phase, then semi, and then full. Full is nothing but 6 pulse, other 2 are 3 pulse, and we have seen 1 2 pulse. So totally it becomes 4 topologies we have seen till date. So for that 4 topology you can have various performance parameter. So you just take it as an assignment. Take a A4 paper, put a tabular column, on the top write all type of topology, and the left hand side you write one by one parameters. Okay, so assumption the device used are ideal, that is they do not have any losses. Actually speaking, see, any law can be disproved. You know there are various laws, okay, like Ohm's law, Kirchhoff's laws, whatever, E is equal to mc square, mass energy relationship, all the law can be easily disproved when you go and touch on their assumptions. Without assumption no law will be there, and all assumptions are only assumption. Actually speaking, that will not be there. Okay, see, you have E is equal to mc square, a well known mass energy relationship which says if we are talking about energy there should be a mass. Without mass there is no energy, but unfortunately the energy from the sun, there is no mass. You don't feel anything coming from the sun and reaches the earth, whereas we have huge amount of energy which is coming from sun. Okay, so that sun is emitting the energy in the form of photons. So photons are invisible. Invisible means mass is 0. If mass is 0, energy should be 0. So for sun, E is equal to mc square fails. Similar way, all laws will fail because when you go and touch the assumptions. Okay, where in E is equal to mc square they will start saying assumption without mass there is no energy, like that they will try to start. Similarly here we are saying that switches are ideal. That is not at all possible. No switch is ideal. Ideal means if you say on, he has to on without any delay, he should on. For that, you know, all the switches are made from semiconductors. they are not conductors, they are not insulator, they are semi, which means they behave both like an insulator as well as they will behave like a conductor. So it will offer some resistance and then only it will get turned on. So ideal switches are not possible, you will have some amount of delay. But for our case, for making our analysis simple, we take all the switches are ideal. Then device have resistive loads. Again, there is no load called as resistive load, all loads are resistive and inductive in nature. Okay, so the first thing is DC voltage on load, we call it as VDC. So VDC is equal to 1 by T 0 to T VL of T dt. It is very easy to understand. VL is load voltage over the period of T. Over the period of T is 0 to 2 pi. So 1 by 2 pi integral 0 to 2 pi VL of T dt. So each and every value you try to calculate, then try to summarize. When you summarize, you will get the total. That is nothing but the DC voltage on the load. Similarly, RMS I have already told. RMS is root mean square value. So it is mean square, so you have to put square root to the previous equation. If you just put a square root, you will get RMS value, that's all. Then comes form factor. Form factor is ratio of the RMS value to the average value. The top we have seen two fellows. The two fellows, if you take from that, you can tell about what is the form factor. See, DC voltage, RMS voltage. When you compare these two, you get a form factor. So it is nothing but VL by VDC. VL is RMS voltage divided by VDC. That is called a form factor. And the last one is called ripple factor. Ripple factor is the amount of AC component present in DC. See, when I say DC, there should not be any change in waveform. It should be a straight line. So you can see here some dotted lines like are there. So this is your AC waveform shape, and your DC, you can see here it is tracing your AC. So I can say this is the AC part on my DC. See, this is just a slope, whereas this is tracing your AC. So what I can say, this part of the waveform is similar to the AC. So that is what they say. Ripple factor is the ratio of AC component present on DC. So when you want to reduce this, you get a pure DC. So ripple factor should be less. So if you go on reducing your ripple factor, your DC will be like a straight line. Then comes efficiency. We all know efficiency is nothing but output by input. So output, we all know, for a converter it will be pure DC, and input is this DC component plus something with respect to source. Okay, so where your power DC is equal to voltage into current. Similarly, PL is equal to voltage into current, and PD is equal to nothing but, see, this is input side, this is output side, this is loss. So efficiency, I can say output by input. So from output you have some input plus loss will give you the output. This is power across the diode. So power across the diode is nothing but, this is P suffix D is power across diode. So power across the diode, which is nothing but some power lost across the diode. So RD is resistance into current. So what will be lost? Lost because of resistance. See, you have a floor. I am taking one bucket of water flowing at, I want the water to reach to the other part of the room. So but some water gets stagnant and some water is observed. All that is, we can put together, say that is the resistance offered by that particular type of floor. So for depending upon the floor, this amount of water which gets stagnant or which is observed will vary. Similarly, So this is playing the role. So this multiplied by I square will tell about that power loss. So remaining is your from your source. So efficiency can be rewritten as, I am substituting here VDC into IDC here. Similarly VLIL, similarly RD I square. So here this IL VD square divided by VL square into 1 by of 1 plus RD by RL, it will be there. And when you see this RD value is less, so this terms get totally removed and you get it as VD square by VL the whole square, which is none other than 1 by form factor square. Okay, that is your efficiency of the device. So efficiency depends on form factor, and form factor is nothing but ratio of RMS value to the average value. Average value is DC, RMS value is AC. So then comes your last parameter which we will compare is transformer utilization factor. See, when you say AC to DC conversion, the input side you have a transformer, so you will have a step down transformer. So how effectively you are using the transformer? See, if you are putting a transformer, you should go for maximum utilization, and that depends upon, defined as the ratio of DC power output of the rectifier to the effective transformer VA rating used in the same rectifier. The effective VA rating of the transformer is the average of primary secondary VA rating of the transformer. So that is what we say, when you put a transformer, you have to decide depending upon your DC requirement. So if you require small amount of DC, then the rating of the transformer also should be less. If you put a very high rating transformer for a small application, source inductance will come into picture, and the source inductance will make the loss to be maximum, or even output will be 0. So see, if I want 5 volt, I should not put a transformer on my input side with output voltage of 230 volt. If I put an output voltage of 230 volt diode rectifier and I do all the such things, that is waste. I have not properly utilized that particular transformer, so you will have more loss. Okay, so that is called as transformer utilization factor, TUF. So now let us move on to the third subdivision of today's discussion, which is firing scheme. So there are 3 types of firing scheme. Firing is nothing but how I am going to turn on how I am going to turn on the thyristor. Say we have told that alpha, how that alpha is been achieved. See, if I want 30, how I am able to get that 30. So that is called firing scheme. So way by which I am going to fire. Nowadays all this firing schemes and all we are not using, we are using only microcontrollers. So today I think you all know the mechanical people, they totally lost their job in the field of automobiles. Okay, in the field of automobile, now only electrical people is going to play the role. Electrical and electronics people is going to play the role, because your car is totally electronic. There is no mechanical portion at all. In engine, olden days we say we have engine, cylinders, valves are opened, closed. Even your accelerator pedal and all, behind the accelerator pedal there will be a rod running, and this rod will go and open and all. Now everything is electronic. Even if you see there is a pedal is nothing but where you go and keep your leg on accelerator, clutch and all. Back side of the pedal itself, the data is converted into digital, and only digital data is going, and everything is digital, and the car itself is totally electronics car, and there is no mechanical part. Okay, so automobile industries is taken from mechanical and hand over to electrical nowadays. So automobile is totally of electronics. That is the reason in 2015 flood, no car was able to get repaired, because the repairing cost is very high, because all the electronics are shorted. So if you want to repair, you have to nearly spend 80% of your initial amount you have spent. So each and everything will have some disadvantage. See, invention will have both advantage as well as disadvantage. So now in your syllabus you have R firing, RC firing and UJT firing. So today let us discuss only R firing and RC firing. So in R firing, what you are doing is, see, this is the thyristor which you want to fire. To fire this thyristor, I should need an alpha. That alpha is made by this R. Okay. See, your AC voltage will start from 0, it will reach as maximum and then it will reach as minimum. So since voltage is rising, similarly current will also rise. So current will gradually increase. So you can fix a resistance. So for that resistance value, current will be 0. Once after that particular resistance value, current will starts to flow. See, if I keep 1 ohm, initially electron will try to come here, it will unable to cross this 1 ohm because total loss. Then if current is increased further, then the current will try to flow. So that is how when you fix this R, you are fixing the alpha firing angle. So greater than this, it will try to travel and try to turn on. So all that thing is only been explained here. So the graph for a resistance of this R2, I can vary this alpha. If I vary this resistance, if I increase this resistance, the alpha will increase. If I decrease the resistance, your alpha will reduce. Okay, that's all about R triggering. It is a simplest circuit. Disadvantage, performance depends on temperature. That is, the value of resistance will change with respect to resistance. If I manufactured in Europe and I have brought to India, then the room temperature itself will vary. So because of the variation in room temperature, the resistance will fall. If the resistance is falling, then alpha will also vary. You may think you are firing at 60, but it will fire at 30 degree itself. When you want to think you will fire in 30, even it can fire at 10 or even at 0. So that is the disadvantage. The performance depends on temperature and the SCR characteristics. Minimum phase angle is typically 2 to 4 degree only. Less than 2 degree and all I cannot fire. Maximum phase angle is still only 90 I can go. Beyond 90 I will lose the control, because see, your current as well as voltage is increasing only at this till in this instant. So after this instant, current starts to decrease. So I have already kept at a resistance where after this resistance value only the current is going to flow. So once this cross here, automatically current itself will reduce. So nothing will pass through here, and that will not allow this transistor to fire. So the control range is only from 0 to 90 degree. So that is the drawback. So for this reason, what we are doing is, we are moving from R triggering to RC triggering. In RC triggering, you make the resistance and try to vary, and that is brought to this capacitance, and this capacitance will discharge and try to turn on. Okay, so capacitance charge during the negative off cycle through diode D2, and then when the SCR is turned on, capacitance C is suddenly discharged to the D2. So D1 protect the SCR during negative off cycle. So it is a protection circuit also, and you can go now beyond 90 degree, because now current will be there to travel and try to turn on even when the voltage try to reduce, since capacitor has charged. Now with the charged capacitance, I can go beyond 90. So that is the advantage for RC triggering. So in RC triggering, you can see here, I can go even till greater than 90 degree. I have shown an example where I am going beyond 90 degree. This increase in current because of the capacitance which is providing. Capacitance is providing the current. So I can provide current beyond 90 degree also. So the firing angle can be brought till 180 degree. So that is the difference between R and RC triggering. Okay. So this just we have shown. You take AC diode, then output of this portion you will have a rectified output. From the rectified, to remove the ripple, I use this thyristor. This is triggered by capacitance. So I can fire anywhere between alpha 0 to alpha 180 degree. So that is possible. So with this we will stop today our discussion. We will continue with